We're going to verify that these two are inverse functions of one another. So we have g of f of n first. So we have g, and we have 2n cubed plus 1. So we notice that this will be the input. So we have cube root, and this is the input, so that's going to replace the n. So we have 2n cubed plus 1 minus 1 over 2. So we have the cube root of 2n cubed plus 1 minus 1 divided by 2. And I don't want to go too fast, but this is the input, and here's where the input was. So you can almost see the resemblance of it. This is the input. This is the input. So you notice that 1 minus 1 is 0. So you have the cube root 2n cubed over 2. The 2's become 1. So the cube root of n cubed is just n. And that's what we want. So now we have to do the other composition. So we have f of g of n. So we have f, and now our input is a cube root of n minus 1 divided by 2. So g of n is the input. Now this is the input. And we're going to input this into this function. So we have 2. Here is the input, the cube root of n minus 1 divided by 2. Remember that this is raised to the third power plus 1. So let me just show you. This is now the input. The input for f. That went into f. So we have 2. That's the input. So we have 2 times the parentheses raised to the third power plus 1. So now we're going to go ahead and do some algebra. Anything that is cubed, the cube root that's raised to the third power, they kind of cancel. So we have n minus 1 divided by 2 plus 1. 2 divided by 2 is 1. So n minus 1 plus 1, that gives you, so that checks. So that tells you that they're both going to be inverse of each other. If you come out with n, or you come out with x, if you come out with the same variable, that means they're inverse of each other. So once again, we're going to check if these two functions are inverse of each other, and we're going to go ahead and do the composition. G of f of n, and we're also going to do f of g of n. So we have g, f of n is negative 1/2 n minus 5 over 2, and this right here is our input. Into g, and g is right here. G is right here. So I'm going to go ahead, and wherever I see an n, I'm going to replace it with the green. So we have negative 2 parentheses, that's our n, minus 5. So you have negative 1/2 n minus 5 over 2, because that was our input. That was our input. So now let's do some algebra. We're going to do the distributive property. Negative 2 times negative 1/2 is was 1, or just n. Negative 2 times negative 5/2. A negative to negative is positive. 2's cancel, so you have positive 5 minus 5. That cancels, so we're left with n. So now we're going to go ahead and do f of g of n. So we have f, and now our input is negative 2n minus 5. Our input is negative 2n minus 5, and that's going to go into there, okay? So I have negative 1/2. Remember, we have an input minus 5 over 2. So this is going to go right there. So you have negative 2n minus 5. Distributive property. A negative times a negative is positive, and that's going to be n. A negative times a negative is positive, and that's 5 over 2 minus 5 over 2. These cancel, so we're left with n, and that does prove that these two equations, or these two functions, are inverse of each other. We are going to find the inverse function for this equation here. So we have y equals 2 parentheses x plus 3 raised to the third power. All I did is I replaced f of x with y. Now my next step is to change the x and the y, because remember, that's what you do when you do the inverse. You're switching the x and the y. So you have x equals 2 parentheses y plus 3 raised to the third power. So now we want to solve for y. So we divide by 2. So we have x over 2 is equal to, and of course the 2's cancel. We have y plus 3 raised to the third power. Since we have a cubic, we're going to find the cube root of both sides. So we have the cube root of x over 2 is equal to, these two cancel, the cube root and the cube cancel, so you're left with y plus 3. And since we want y by itself, we're going to subtract 3. So we have the cube root of x over 2 minus 3 is equal to y. And we normally write it in a function notation. So that's the inverse of f equals the cube root of x over 2 minus 3. So we're going to write the inverse of g of x. So we have y equals 2x plus 10. It makes it easier if you make g of x y. Now our next step is to switch the y and the x. So you have x is equal to 2y plus 10. Subtract 10 from both sides. So we have 2y equals x minus 10. And then our last step is to divide by 2. So y equals x minus 10 divided by 2. So the way we write the inverse is the inverse of x, of g, is equal to x minus 10 over 2. So we're going to find the inverse of this function. Y equals negative 1 over x minus 2. So we're going to switch the x and the y. So we have x equals negative 1 over y minus 2. I would multiply by a negative 1. A negative times a negative is positive, so you're left with 1 over y minus 2, and you have negative x. So the next step is to multiply by y minus 2 to both sides. Y minus 2 to both sides. So these two cancel. So you have negative x times y minus 2 equals 1. You have negative x times y. Negative x times negative 2, so it's negative xy plus 2x equals 1. Subtract 2x from both sides. So you have negative xy equals 1 minus 2x, and then divide by x. divide by x. So y equals 1 minus 2x over negative x.